So now that we added this file feature and we're able to write to a file and read from a file, we should also take a look at error handling. Because I did mention that, for example, when it comes to reading from a file, you could get an error. For example, if that file doesn't exist. To show you what I mean, I will delete this file here, this balance.txt file. With that, reading from that file should fail when the app starts because the file doesn't exist. Therefore, if I run the application, it actually works. But if I check the balance, it of course has a value of 0 in there. So the great news is that indeed here the app doesn't crash, because read file, when it doesn't find a file, does indeed generate an error, as you'll see in a second, but it does not crash your application. Instead, in Go, error handling typically works a bit differently than it does in other languages. Because if you've worked with other languages, you might be used to certain actions or problems crashing your code. And in other languages, you can then often use try-catch statement to wrap code that could potentially fail, to catch errors and define code that should run if an error occurs. That is not how it works in Go, though. Instead, in Go, functions are written such, and your functions should be written such, that errors don't crash the application. Instead, read file, for example, will simply return an empty byte collection if it fails to find that file, which is then converted to an empty string, which is converted to the value 0 when parsing it as a float. That's why we see the value 0 here if we check the balance. But that's not all Go does. Instead, for operations that could fail, it is quite common that functions return such an error thing as a second value. And that's the value we can accept and store as a second value here when calling that function. So here I'll store it in a error variable. And what you then typically do in Go is you add a if check, where you check if error is not equal to nil. Now, nil is a special value in Go. It basically stands for the absence of a useful value, you could say. And error, this error thing here, will be nil if we have no error. So here, if we check if it's not nil, that means that we have an error, because error is not nil, which it would be if we had no error. And therefore, we can now use this if statement and its body to define the code that should run if something goes wrong with reading that file, because it maybe wasn't found. For example, here we could then return our default balance, which could be 1000, whatever you want. You can also define any other logic you need. It's totally up to you. But that's how you can handle errors. And we can do the same thing down here for parse float. Because parse float can also yield an error. If converting the string to a float fails, for example, because it contains some text that simply can't be converted to a number. For example, the text hello can't really be converted to a number. So therefore, here we can also accept this error and also check if error is not equal to nil and define our backup logic here. For example, to again return 1000 as a value or whatever you want. And with that, we made this code more robust. Now, what we could also do here, instead of just returning such a default value here, is return a default value and also our own custom error object. So that in the place where we call this function, we could handle this error. For example, to output some error message to the user and then still use that default value if we want to. And returning a custom error is quite straightforward and easy to do. First, I'll make Go aware of the fact that I'll return multiple values. And the pattern here is that your second, or in general your last value, will be that error object. And it will have a special type of error. So that's a special type built into Go. And you can then create such an error with help of the built-in errors package. So for that, you need to import the errors package, which is part of the standard library. And with that imported, you can create a new error by calling the new function that's part of that package. As you see, that produces an error value, and you can simply attach an error message to that error. For example, failed to read file, or failed to find balance file, something like this. And then here, for the second error handling if check, we can produce another new error where we say failed to parse stored balance value, so that we have different error messages for different problems. Now here in the success case, where we had no error, we also have to return a second value, and here we should return that special nil value. So comma nil, which means we have no error. Well, and now we can go to the place where we call getBalanceFromFile, and since this now returns such an error value, we should accept a second variable here, error, for example, which we can now also use to check if it's not equal to nil, which, as you learned, means that we have an error. And then here we could, for example, output this extra error message and output error in a new line, and then below that, the error value. And you can refer to the error value like this, and it will automatically output the attached message. And then below that, to set this apart, I'll output a couple of dashes. And that's how we can add our own error handling, how we can handle the built-in errors and then generate our own errors, and how we can handle those custom errors as well. So with that, if you make sure that you have no balance.txt file, if you run this application, you see I get this error here at the top. Now, of course, if I deposit some money, let's say 500, I'll actually write to the file again, and therefore it will be recreated. And it now contains 1,500 because I added 500, and 1,000 was that default balance value we returned. So that value still got used because in our error handling code here, we just make sure that we print this message, but we did not block the execution of the rest of this file.